The last thing we worked on before testing was these things here. Oops, where is it? Right here. Sine, cosine, tangent. Phones, put those away, please. Okay. If you have your phone, we're going to need your phone, but not right now. Okay. This is what we worked on. Right? This is what we worked on. We're going to come back to that today. Today, we're doing the opposite. Today, we're doing the opposite of sine, the opposite of cosine, the opposite of tangent. We're not going to really focus on these today, but we're going to do the opposite. It's called inverse. Okay? So when do we use the opposite? When do we use inverse? Is when we want to find a missing angle. If we want to find a missing angle, we use inverse. Okay? If we want to find a missing side, like we did here, we use regular sine, regular cosine, regular tangent. Okay? So the first thing we're going to do is work with those. So how do we do it? Well, there's 4 steps. I put them on the board. Okay? When we're trying to find a missing angle. So when they work with triangles, sometimes they'll use theta. It's a Greek letter. If you don't like that, just put x. Just put x. So if you don't like theta, it's a variable. All it means is a variable. They use it with angles. So if you don't like that, just put x. It's the same thing. It's a missing part. We don't know. Okay? I know 2 sides. I know it's a right triangle. I need to know this angle. So this is the angle I need to find. If you don't know the angle, we use inverse trig. Okay, so first step. Which one would I use? Sine, cosine, or tangent? So if I need this angle here, what do I know? Do I know the opposite? Do I know the adjacent? Do I know hypotenuse? Which ones do I know if I'm at this angle up here? I know opposite, right? I know opposite, and I also know hypotenuse, right? So let's go back to what we did before. Which one said opposite over hypotenuse? Sine, right? That's the one we're going to use. That's step 1. So for our triangle, we're going to use sine. Step 2, make a equation. So I know I'm going to use sine. I don't know what angle it is, so I'm going to use x. What would sine be of that angle? What would the opposite over adjacent or opposite over hypotenuse be? 12 over 56, right? That's what it would be. That's step 2, equation. Step 3 is the trig loop. Kind of like the log loop. It looks like the log loop, except there's no logs. So the loop looks the same. You start with sine, you go to the fraction, and then you come back to the variable. Sine changes. It doesn't change very much. It goes from regular sine to inverse sine. How does that look? It looks like this. It looks like sine, but with a -1 power. So if it was cosine, it would be cosine, inverse cosine. If it was tangent, it would stay tangent, just inverse. That's the first thing. That becomes that. Next, we went over to the fraction. So the fraction is going to move over here. Parentheses 12 over 56. The last thing it hit was the x. Now the x is on the other side. That's step 3. That's the trig loop. Last step, calculator. So we're going to go calculate that. Where's my calculator? So these are the regular sine, cosine, tangent. I don't want those. I want the ones with the inverse. To get those, they're there. You just got to look up the function key. Function. If you hit the function, they'll be there. right underneath sine, cosine, and tangent. I want the -1 guys. So I'm going to hit the sign. Division. I had 12 over 56. Yeah, 12 over 56. There's my answer. It says round to the nearest tenth. Round to the nearest tenth. The tenth is 3. So the 7 says go up 1, so it's going to be 12.4. 12.4. Since it was an angle, it needs a degrees. And you're done. That's that missing angle. That guy was 12.4 degrees. Okay. Alex, phone over. Okay. Let's try that again. So now we have to find this missing triangle or angle. Okay. Step 1, if I'm up there, which am I going to use? Sine, cosine, or tangent? Do I know opposite? Do I know adjacent? Do I know hypotenuse? Which of those do I know? All right, sine again, right? Opposite is 7.4. Hypotenuse is 12. So I'm going to use sine again. So we're going to say sine of x, that's the angle, equals 7.4 over 12. That's step 1 and step 2. Loop. Sine becomes inverse sine. Fraction comes over here. X goes over there. Calculator. $7.4, 12. 38.07. So round up, 38.1. 38.1 degrees. Since it was an angle, it's got to get a degrees. 38.1 degrees. That's the hardest part about what we're going to do today. Every other thing we're going to do on the other side, you've done before. That's the only new thing. Okay? That's the hardest part. I think the hardest part about today. Okay, so the last thing we're going to do. Solve right triangles. Now we're going to solve right triangles. What does that mean when I say solve right triangles? It means we need 6 things. I need to know what all 3 sides are, and I need to know what all 3 angles are. That's how you solve it. So I need 6 things. Okay? So what do we use? What are our tools? Well, one of them you learned in 8th grade. It's called Pythagorean theorem. Okay? When do we use Pythagorean theorem? When we're missing. This is for finding sides. Trig ratios is also for finding sides. Those are what we did last time. If I need to find sides, I use one of those 2 guys. The last thing is inverse trig. That's when I'm finding angles. So if I'm trying to find a side, I'm not going to use inverse trig. If I'm trying to find an angle, I'm not going to use the regular trig ratios or Pythagorean theorem. These are the 3 things you're going to use. Okay? So solving right triangles means give me all of the angles and all of the sides. So the first one, number 3. Every triangle's got 3 sides. Every triangle has 3 angles, or else it wouldn't be a triangle. So the first thing I need to do is list what I need to figure out. So I'm going to do the sides first. The sides. This guy has 3 sides. It has from x to y. That's one side. It has x to z. That's another side. And then y to z is the last side. Those are the 3 sides that it has. Some of those I know, some of them I don't know. Now the 3 angles. Well, the first angle is angle x, then angle y, then angle z. That's going to be my answer key right there. To solve this problem, I need to answer all 6 of those questions. Some of them I know. Like, which ones do I know already? X, Y, right? I know X, Y. From X to Y is 23. From Y to Z. What if I put, instead of YZ, what if I put ZY? Is that okay? Yeah, it doesn't matter. The distance from school to my house is the same distance from my house. It doesn't matter which one you start with or which one you end with. It's the same distance. So 34.5. Okay. What else do I know? What else do I know?
The angle of x.
Angle of x, right? What is the angle of x? 90 degrees. I know that one because it's a right angle. They'll always give you at least 3 to start with. And you have to find the other 3. Sometimes they'll give you 4. Sometimes they'll be nice and give you 4 things. Okay? All right, so the first thing I got to find is xz, xz. So what am I going to use to find missing sides? The Pythagorean theorem is one way. Trig ratios is another, right? Okay, so when can I use Pythagorean theorem? When does Pythagorean theorem work? A squared plus b squared, or leg squared plus leg squared equals hypotenuse squared. When I have, what's that?
When you're looking for hypotenuse?
Not necessarily. I can use it when I'm looking for a leg. The key is I have to use it. I have to know 2 of them. If I know 2 of them, I can solve for the third. So do I know 2 sides? I do. I know x, y, and y, z. My question is, are they legs or are they hypotenuse? So let's see. Leg squared plus leg squared equals hypotenuse squared. So 23, is 23 a leg or is it a hypotenuse? It's a leg because it makes up the 90 degrees, right? It makes up 90 degrees, right? So I'm going to put 23 here. Do I know the other leg? No. So I'm going to leave that one as a leg. Leg squared. Do I know the hypotenuse? 34.5. Solve for the missing part. So 23 times 23 is 400 or 500 and something. Let's see, 23 squared, 529. 34.5 squared. 1,190.25. 1,190.25. What do I do next? Yep, subtract 529. So that number that I just calculated minus 529, I get 661.25. 661.25. So is that the distance from x to z? Is it 661.25? Seems a little big. Square root it, yeah. Square root it. And then I'm going to round it. If it is a decimal, round it to the 10th. So the square root of 661, square root 661.25. It is a decimal, 25.714. It says round to the 10th, so it's going to be 25.7. 25.7. Okay. Okay. So now I got to figure out the other two angles. So what am I going to use to figure out missing angles? Right here, yeah. There's a reason I moved over here. It's right behind me. Same thing you did on the front side. Now, which one are you going to find, y or z? It doesn't matter. Doesn't matter which one you find first. I'll find y since it comes first in the alphabet before z. So if I'm using angle y, which one am I going to use? Sine, cosine, or tangent? It's kind of a trick question. Any of them, yeah, it's any of them. That's why it's a trick question. Can I use sine? Yes. Can I use cosine? Yes. Can you use tangent? Yeah. So it doesn't matter which one you use. I use sine on the first one, so I'll use cosine on this one. That's the reason I'm doing it. Could I use sine? Yeah. So cosine of y. So if I'm at y, which is the adjacent to y? 23, right? Y to x, x to y, 23. 23 is adjacent. And the hypotenuse is still 34.5. Okay, that was step 2. Step 3, loop. Cosine becomes inverse cosine. Fraction comes over here. Y goes over there. Calculator. $23. Don't use regular cosine, use inverse cosine when you're using your calculator. 23 divided, 34.5. 48.189. Round to the nearest tenth. 48.2. 48.2. Since it's an angle, it gets a degrees. 48.2. That's y. How do I find z? There's a short way and there's a long way. It don't matter to me which one you use. I know which way I'd rather use, but it doesn't matter to me which way you use. There's a short way to do it and there's a long way to do it. Does anyone know the short way? I'll give you a hint. The long way involves this. Not hard, but it's a little longer. What is the shorter way of doing? You're getting there.
You have to compare the other two angles somehow.
Compare the other two. I know the other two. Triangles can't go over 180.
180.
Add it and subtract.
Oh.
There you go. Add it and then subtract it from 180. Yep. Add it and then subtract it from 180. So you go 180 minus the two that I know. 48.2 and 90 degrees, right? That's the fast way to do it. Just put that in your calculator. .2 plus 90. 41.8. Done. I know every angle. I know every side. Solved. Okay? That's solving a right triangle. Mm-hmm. When he gets back, you can go. Okay? All right, let's do number 4. So number 4, I'll do with you, like we did here. Number 5, you're going to do on your own. Okay? Because on the quiz next week, that's what I'm going to give you. I'm going to give you a triangle like this, and I'm going to say solve it. Give me the rest. Okay? So it's good practice. So let's go to number 4. Let's do number 4 together. So the first thing, since it says solve the right triangle, is list everything that I need. Okay, let's start with the sides. A to B, B to C, A to C. And then there's 3 angles. Angle A, angle B, and angle C. Okay, what do you know? Which of those do you know? I know A to C is 16. I know angle A is 35. I know angle B is 90 degrees. And that's what I know. So it doesn't matter which order you go in. I would do the easiest first. Which one of those missing 3 would be the easiest to do? C, angle C, right? They all have to be 180. So angle C has to equal 180 minus the 2 other angles, right? Just like I did on the last one. So let's see. Good. Let's see. $35, $55. So the angle has to be 55 degrees. Okay. Got 2 more. So now I got to find AB and BC. Doesn't matter which one you start with, but I need to find sides, right? So if I need to find sides, I'm either going to use Pythagorean theorem or sine, cosine, tangent. Why is Pythagorean theorem not okay for this one? I only know one side, right? I only know one side, right? So I have to use the trig ratios. Okay, all right. So the only angle that well, besides the 90, we never do the 90 with trig ratios, but the one that I do know besides that is A, right? So do I know opposite? Do I know adjacent? Do I know hypotenuse based off of A? Hypotenuse, right? I only know hypotenuse. So based off of A, let's find opposite first. So let's find this side here first. I could do here, it doesn't matter which one you do first. You could do AB, you can do BC, it doesn't matter which one you do first. Since I did BC first, that's going to be opposite, right? Opposite over hypotenuse, which is sine. Regular sine, not inverse sine. So sine of A, oops, I don't know if I'm going to put A. I'm going to put 35 degrees because we know what A is. 35 degrees is opposite over hypotenuse. This is what we did before, the last thing we did before testing. I'm not going to do the loop. I'm not following these guys because I'm not finding inverse. I'm not finding angles. I'm finding sides. Okay, so if I want to get x by itself, what do I do to both sides? Multiply by 16. Do the opposite. Calculator. 16 times sine 35 degrees. 9.177. Tenth would be 2, so 9.2. 9.2. So that's BC. BC 9.2. One more. So again, there's two different ways to find AB. You can use the same way we just did, or you can use Pythagorean theorem, right? Because I know two sides now. Let's say I just did the way we did before. So now let's say I'm trying to find this guy. Well, now it's not sine, it's cosine. Cosine of 35 degrees equals x over 16. Solve for x. Multiply both sides by 16. Thirteen point one. Done. Okay. All right, so now you're going to do example number 4. Example number 4. There's 6 things you need to find. Okay, 6 things you need to find. So example number 5. Do that one on your own and we'll be done. If you can't find them all, find as many as you can. 3 are given. I'll give you that. So you should be able to get 3 pretty easy. So I have 2 sides and 1 angle. That's kind of like the one we did for number 3. Number 3, they gave us 2 sides and 1 angle. Number 4, they gave us 2 angles and 1 side. So to find the third side, Pythagorean theorem. So 19 is a leg. The other leg, I have no clue. That's what I'm trying to find. And then I know the hypotenuse is 27.8. Nineteen times 19 is 381. 27.8 squared. 77284. 772.84. Subtract 381. Uh-huh.
19 squared is 361.
Is it 361? Thank you. $361. Okay, there we go. So minus 361, 411.84. That's way too big. Square root. Round, we get 20.3. 20.3. Oops. Okay. Now we got to find an angle. Two angles, in fact. Well, missing angles. So let's start with the one that's missing. Let's start with the guy up here. E, angle E. You could start with D, but since E's already up there, I'll just start with E. So which one could I use for E? Sine, cosine, or tangent? Any of them. Any of them. Doesn't matter. I'll use tangent. I haven't used tangent today, so I'll use tangent just to put in your notes. So tangent is opposite over adjacent. So opposite is 19 over adjacent 20.3. So tangent of E, since I don't know E, opposite over adjacent. Could I have used sine? Yes. It would have been a different fraction, but I could have used sine. I could have used cosine. It would have been a different fraction, but you could have used it, yes. Loop. So it then becomes inverse tangent. Fraction goes next. Calculator. $19 over 20.3. 45.1. 45.1. 43.1. Sorry, yep. 43.1. Degrees. Last part. You can do sine, cosine. You can do this again. Or you can just see, since I know two of them, what's the third one got to be? Well, they all got to equal. So for angle D, it's got to be 180 minus the two that I have. I think it's going to be 46, 36.9. 36.9, is that what you got? Done.
I don't know if it's right because they've got to add up to 180. It's 46.
Is it 46? Okay.
46.9.
Yeah.
Let's see. Easy way to check. 180 minus parentheses 43.1 plus 90. 46.9. Yep. Okay. All right. All right, so there's tape here. Let's see. Tape kind of got messed around. If there's tape in the back, so if you guys need tape, there's tape in the back. So if you're in the back and you don't have tape, grab some from the back for your row, please.